All right, now let's take a look at solving an equation where we have a rational exponent in there. So first, let's take a look at this first bullet point. It says to solve equations of the form x raised to the m over n powers equal to k, we have to raise both sides of the equation to the power n over m. And if you look, you can see this n over m, that's the reciprocal of m over n. So whatever the power is, you have to raise both sides of your equation to the reciprocal of that. And then if either your m or n value are even, then we say that x to the m over n power raised to its reciprocal is equal to the absolute value of x. So let's take a look at this example and work something out. So as you can see over here, the first thing we want to do is isolate our expression that's raised to a power. And here, that's everything inside these parentheses. So we want to get this x plus 1 to the 2/3 power by itself on one side of our equation. So to do that, we're going to divide both sides of our equation by 3, and that will give us x plus 1 to the 2/3 is equal to 4. Now we take a look at our next step, and that's going to be to raise the expression to the reciprocal power. So here, this x plus 1 is raised to the 2/3 power, so we're going to have to raise both sides of our equation to the reciprocal of that, which is 3/2. So we're going to raise both sides to the power of 3 over 2. And now, if we take a look, since we have a 2 in either the numerator or denominator of our fractions, we have to take the absolute value of this x plus 1. So after we raise it to the power, since either our numerator or denominator has an even number, in our expression is the absolute value of x plus 1. And now the absolute value of x plus 1 is equal to 4 to the 3/2 power, which is equal to 8. So now our next step, we have to simplify and then solve, right? So we have this x plus 1 inside absolute values. So if you remember, when we're solving absolute value equations, we have to make two equations out of this, with one being equal to a positive and one being equal to a negative. So if we do that, then we have the x plus 1 is equal to 8, or x plus 1 is equal to negative 8. And now we have equations that we can solve and find out what our values of x will be. So we go ahead and solve these, and we get that x is equal to 7, or that x is equal to negative 9. So now we have two solutions, but remember, we have to check for extraneous solutions, because one of these, if we plug them back in for x in our original equation, it might make a statement that's not true. So let's go ahead and do that check, take a look at it. So if we take a look here, if we plug 7 back into our original equation, we end up with 12 is equal to 12. That checks out. And if we plug a negative 9 in there, then we end up also with 12 is equal to 12. So both equations hold true for both values of x. So both of these values of x are going to be our solution to this equation right here.